Hi everyone. Welcome to a new episode of the Unthinkable Tech Podcast. I'm your host Anmol Satija, and as always, I'm thrilled to have you join us on this exciting journey where we unravel technologies that are shaping our future. Today's episode is particularly exciting as we are going to cover another buzzword in the tech industry, which is as intriguing as it is important. I'm talking about small language models. It's just a matter of recent times when LLMs, that is, large language models, captured headlines filled with their impressive capabilities. But their sheer size came with heavy cost, storage, resource requirements, which limited their accessibility and applicability. And there is a saying, less is more. And this minimalistic approach has made its way into the tech industry with SLMs. It's an effective, compact alternative to LLMs to democratize AI for its diverse needs. It promises to shine on efficiency, accessibility, and customization. Even big players like Apple and Meta think of it as an integral part of the future ahead. So in today's episode, we are going to unpack the nuts and bolts of small language models. What are they, how they work, and why they might just be the next big thing in the tech. So whether you are a tech leader, tech enthusiast, or just someone who's curious about the future of AI, stick around. It's going to be an enlightening conversation. And now, to get started on this conversation, I would like to invite Prabhanshu Mishra, who is a senior leader in the tech space and has a fair understanding of AI. Welcome, Prabhanshu. How are you doing today?
All right, Anmol. Thank you so much for having me for this podcast. And I must say that I've been listening to your past podcast series, and those has been really interesting to listen to the previous podcast. So what question did you have for me today?
It's great to know that, Prabhanshu. Thank you for listening to our podcast. Now let's get going with our conversation. Maybe we can start by first understanding what language models are, and specifically small language models, and how did they emerge?
All right. So I believe small language models and the large language models, these topics are in debate right now because initially what we call it as the small language models based on the parameters. Even today, small language models has increased their parameter size. So before actually deep dive into the small language models, let's try to understand what the long language models are, right? So if I have to talk about the small language model, particularly in the language model, particularly in the artificial intelligence and machine learning, they are designed to understand, generate, and manipulate the human languages. So these models range from a small one and the small language model to the complex architectures like GPTs. Now, let's understand the history behind the evolution of those models. So generally what I do, I just bifurcate this history into the three stages. The first stage of this evolution of language model is statistical language model. Previously, artificial intelligence and machine learning, has been derived or has been developed with all such statistical models. So initially, the early models such as N-grams model and the hidden Markov models are based on the probability of the words. So initially, these models are trying to predict the probability of the next word. But the major problem or the major concern with these models are their inability to capture the longer dependencies or the context of the whole sentences. So let's consider a scenario. I have a huge paragraph. Probably these model might not be able to predict the next word accurately. Now, the another step or the another stage where all such machine learning algorithms are getting into place. When we say machine learning algorithm, probably those are, I'm talking about neural networks, or specifically the recurring neural network, because the recurring neural network takes account for the previous data sets. Right. So, if I have to talk about these particularly neural network, they are better at understanding the sequences and could remember the information for a longer period of time. So probably one of the use cases for these neural network is predicting, let's suppose, the stock analysis. So because the stock are the time series analysis, right? So if I would like to predict the stock, probably in the next second, these neural network are going to be the best fit for this particular use case. And specifically, considering this particular property of those neural network, people are utilizing in the language model itself. And then there is what we are saying is the transformer models, right? So if I talk about the transformer model, this architecture is based on the self-attention mechanism. And they have been performing very good when it comes to actually predicting the next word, I would say, right, in the overall language itself.
That actually sounds interesting, Prabhanshu. Can you help our audience understand transformer model? Just a brief explanation.
Yeah, sure, Anmol. So if I have to talk about the transformers are a type of model widely used in processing languages, images, and other type of data. The key feature that makes transformer effective is their ability to handle data in chunks. So if you know that at the heart of the transformer is the self-attention mechanism. And for that, there's been a paper that has been published in the year of 2017 named Attention is All You Need. So if you have to take an example, that imagine you are in a room with a group of people. Those are talking about the complex topic. Now, instead of listening to one particular person, instead of listening to a overall group, consider that you are listening to one particular person or maybe a word that a one particular person is speaking. This is what basically how the transformer or self-attention works. Similarly, it helps model decide which part of the input data are most important, thus enabling it to understand and generate the information more effectively. Right. Now, if I have to talk a little bit detail the steps of the transformer model, but I would not go into much detail here. But the first step of the transformer basically input representation. So in the transformer, if the input data, let's suppose the text, is first converted into the numerical form called embedding. It's a vector basically. Now the second step is basically self-attention mechanism. Now in self-attention mechanism allows the input to interact with every other input, which is very, very important. And it basically determines how much focus it should give to the other part of the data. Now, this is basically done with some metrics calculations such as query, key, and value calculations. Now, once this has been done, the next thing that it does basically calculate the self-attention scores. And by comparing each query with all such keys. And then the next, which is another step, is the positional encoding. Now, positional encoding, you consider that since the transformer don't possess the data in sequence like older model, they need to find a way to understand the order of the word in sentences. So this has been basically done through the positional encoding, which are added to the input embedding to provide the information. Now the another is the layer of the transformer. So as I was mentioning, the transformer model is composed of multiple layers, and each layers containing two sublayers. One is the self-attention layer, which we already talked about. And the second is feed-forward neural network layer, which basically process the output of the self-attention layers. Now, each of these sub-layer is followed by normalization. And then after data passes through the several layer of attention and these feed-forward network layers, the transformer output is generated. Now, this output are the vector, which is basically used to predict the next word. So in some simple word, if I have to explain that all such calculation is being done is generally to predict the next word, but by taking all the input into the consideration, which is very, very important part of it. Right. Now, since we have been talking about large language model and small language model, if I have to explain the difference between which you have asked previously, and I have taken so much time explaining the other basics, but the one and very important differentiating factor is the parameters. So how do you define the parameters for any models? Is basically they are the variables that the model uses to make the prediction. So if I have to explain the parameters in simple word, we know a certain equation like y is equals to mx plus c, where M and C is nothing but the parameters. Now, the parameters basically represent a concrete part of model that can change or adapt based on the data it has been trained on. Now, if I have to differentiate between the parameters that large language model uses and small language model uses, so consider GPT-4, which we all are using today. It is using 1.8 trillion parameters. Right. Now, if I talk about Gemini Ultra, which is from Google, it is utilizing 1.5 trillion parameters. Now again, counterpart to LLM, if you consider small language models, so which is 5.2, now it is utilizing 2.7 billion parameters. So you consider the drop in the parameters from 1.8 trillion to 2.7 billion.
That's a huge difference.
And specifically, if I talk about Llama from the Meta, it is utilizing 7 billion parameters. Now, you might be wondering that reduction in the parameters, what difference it is going to change in the life of the business user, basically. So first important changes that these decrease in the parameters bring on table is one is the computational resources that is required for the training and as well as the generation of a desired output. We call it as inferences, right? Now, since the computational resources required are less, then it brings two benefits. One is on the cost front, and second is the deployment on the CPUs as well. So you consider the edge devices. Let's suppose I have smart watches. I would like to deploy a small model over my smart watches. Or probably there could be the cases where I would like to utilize this model in a remote area as well, where the cloud connectivity or internet connectivity are not that much, where these models are going to be very much useful. All right. Now, again, definitely we'll be talking a lot more about those models. But if I have to talk about one very, very interesting topic with all such large language model, there is also a risk of algorithmic biases. I believe you might have heard about this particular term, which is being introduced via data sets that are not sufficiently diverse. So that's also a very interesting things to understand, because the way these models are generating the output, sometimes those are not as expected.
Yeah, this is actually a common concern. So maybe you can help us understand what algorithmic biases are and what is its impact.
All right, Anmol. So let's deep dive into the algorithmic biases a little bit on a brief level. Now, if I have to explain the algorithmic biases, the bias can manifest in machine learning model like those used in AI and is often a result of data used to train these models. So if I have to explain it in a very simple word, algorithmic biases is something where the model is giving the output which is not required or which is somehow is not true. Now, if we have to explain the algorithmic biases, the first you can consider that, let's suppose the data on which the model is being trained is not a representative of the real world distribution, or probably it is being skewed toward the certain groups. Now let's consider one example. So a company built a facial recognition system to identify the customer in store and offer a personalized deal. Now, if the training data predominantly consists of the image of the people from a certain ethnic group, probably the system might be less accurate for a people those are not present in the data set. Now this is the problem, and that is why, whenever we start training these models, we always take care of the input data, because the input data is correct, then probably our system is going to give you the desired output that is required. It has to be normalized basically. Now, second possible fault in this is on the data labeling side. So let's consider a scenario. The process of labeling the data can introduce the human biases or error, which are then learned by the model. That can also be the possible problem. And the third, which is more prominent problem, is on the feedback loop. So, the continuous learning from the user interaction. So we are giving the feedback to the model that, let's consider a scenario that, hey, this is not supposed to be like this, or probably the model is generating a desired output, and we kept on giving the reinforcement to the model that this particular output needs to be generated in a particular tone. And after giving a lot of input or these reinforcement to a particular model, sometimes we did not even recognize that how the model is being transformed. And then the model will start giving the output, which is probably not required, right? So this is particularly what I would say the algorithmic biases are. Definitely, there are a lot more things that is there when it comes to fine-tuning those models and generating the desired output. We take care of those algorithmic biases by various of the techniques and the strategies. Probably we'll discuss this in our later podcast as well.
Right. That was quite an explanation, Prabhanshu. Thank you for that. Moving further, I want to know, how are these SLMs impacting certain industries? Maybe you can explain with some examples.
Absolutely, Anmol. So, I mean, the way the developers are utilizing small language models are even blowing my mind right now, because the thing is, people are utilizing those SLM models in performing the various tasks that people cannot even imagine once they've been arrived. So I got to know that few developers is utilizing this SLM in order to playing of certain video games, which requires a very detailed cognitive ability of the human. And if I have to speak about the BFSI domain or a particular industries, now let's talk about the BFSI domain, where on-device processing for the mobile application, banking application is required. Now, if I have to talk about the challenges with the LLM, the large language model significantly requires the processing power, bandwidth, and constant connection with the cloud servers, which is when it comes to small language model, they are lightweight and can be deployed directly on the mobile devices, which basically allow them for a real-time processing without needing the constant server communication. Now, having said that, this basically improves both the user experiences as well as data security, as the sensitive financial information does not need to be transmitted frequently for generating the inferences. Now, if I have to take certain examples, what kind of queries or maybe what kind of output those model can generate. So something like they can give you the advice on spending, the kind of spending you are doing, or probably certain answers on the transactional queries as well. They can do it.
Okay. Actually, it seems like SLMs can act as a catalyst for customers in areas with limited connectivity or those concerned with data privacy.
Yeah, absolutely. And now I'm even much more excited when it comes to their application in the healthcare, because personal health assistant are now booming, right? Most of the health tech companies are integrating their product with all such large language models, chatbot, and personalized recommendation and personalized treatment plans, everything. But when it comes to the challenges of implementing such chatbot or personal health assistant in the remote areas, it becomes very, very difficult because of the communication with the cloud. So this kind of problems can be easily solved with small language model, because it can be integrated into the local system or the devices with a limited connectivity and still perform the task like symptom checking or basic health monitoring effectively. Now, if I have to talk in one of the pilot study, health devices using small language model handled daily patient queries and provided a basic diagnostic support with over 90% accuracy, using only the data available on the device without having any internet access.
Okay. The fact that these models can operate independently of high-speed internet connection means that personal health assistance can be more accessible to those who might otherwise be left out due to the infrastructure challenges.
Correct, absolutely. And not in terms of utilizing those model in the areas where direct consumers are exposed, but let's consider the example of robotics. Now, in the field of robotics, what happens specifically in the challenges with the LLM, operating the robots in an isolated or extreme environment like underwater condition, or maybe somewhere where the space are very restricted, often faces a challenge due to the lack of reliable high-speed internet connectivity, which is required for the cloud-based LLM. Now, the advantage of the SLM, specifically when it comes to robotics, can be embedded directly into the robotic system, allowing for autonomous operations even in the environment with a limited or no connectivity. This will allow the robots to actually perform the complex task in a confined environment as well.
Yeah, right. It means that organizations using robotics in remote areas, like you mentioned, deep sea exploration or the space mission, I would say, won't have to really worry about the connectivity issues that typically plague cloud-dependent technologies.
Correct. Absolutely.
Now that we have talked a lot about what SLMs are and where they can be utilized, so there must be some hurdles associated with it, right? Could you share some insights into the main challenges that companies face during the development and deployment of SLMs?
Yeah, absolutely. I think there are many, but generally what I do, I just bifurcate those challenges into three major categories. The first is the technical challenges. Those are related to the technicalities of development. Second important is the ethical challenges, and the third one basically which relates to the business challenges. So if I talk about technical challenges, one and which is very crucial is the data quality and availability. So SLM, as we discussed, requires a high quality of the data. So poor data quality, such as biased or noisy data, can lead to the model that perform suboptimal. Second is availability on the data quality side, which is access to the diverse and representative data set is crucial, because if it is not there, probably there is going to be the biasness in the model performance. And second, technical challenges would be model generalization. So probably we might have trained our small language model for one set of data, which probably will not perform good in terms of generalized task, which is basically the queries that has been asked on a unseen data, you can consider. And the third technical challenges would be resource constraint. So as we all know that deploying the SLM in a resource constraint environment such as mobile devices or edge computing platform requires a efficient models that uses a less computational power and memory, which is very difficult to attain. And currently people are also, there's a growing demand in terms of for a energy efficient model that can reduce the overall carbon footprints as well. So if I talk about technical, these are few challenges that currently coming into my mind. Now, when it comes to second category of the challenges, which is the ethical challenges, which we talked a lot about, is the biases and the fairness. So SLM can inherit or even amplifies the biases present in the training data. So let's consider a scenario. I have trained my SLM model in giving the customer queries response from a set of customers that comes from a particular community. Right. So probably they'll give you the answer, which is biased to that particular community. So that's the ethical challenges, I would say. And the third one, and the third category of the challenges is business challenges. So one, which is very crucial for any business, is the scalability. So the balancing the cost of scaling the small language models with maintaining the performance and the speed is a business challenge that directly impacts the profitability and user satisfaction. So, we need to figure it out that, if I would like to scale a particular small language model, what is the ROI that I will be getting out of, right? Because any investment decision has to be backed by ROI calculations, right? So this is the business challenge, I would say.
Right. Given these obstacles, now I'm really interested to know what strategies or approaches you recommend to effectively address these challenges.
Again, the answer is there are many, but one of the key factor that generally I takes into consideration is the data curation and enrichment. As in AI, we always say the better the data is, the better the output that you will get.
Right.
So invest in robust data curation process that ensure the quality and the diversity of the data set used for the training SLM can actually enhance the performance of any particular SLM.
I would agree to that, Prabhanshu. And there is one more challenge that companies usually face. That is the dilemma of choosing an off-the-shelf small language model or investing in custom development. So could you walk us through the framework or the key that one should weigh when deciding between adapting to an existing model versus building one from scratch? What factors should businesses should consider in this decision?
Absolutely. So generally, what we do, we follow this 5-step approach. So let's talk one by one. The first step is basically defining the business and technical requirement, which generally we do in any development projects. So first important aspect that we need to consider is the business need. So when we say business need, what is the scope and the scale of that particular business problem? So we need to define a specific business problem that the SLM is intended to solve, and scale at which these model needs to be scaled, probably in the future of, let's say, 4 to 5 years down the line. Second is the budget constraint, because that is very, very important. So we need to also get the factor in that what is the overall budget that I have allocated for this particular project from my higher management. And the third, which is very, very important, which is the timeline. So we need to identify whether it's a very urgent need, or probably I can consider getting it developed or rolled out in the near future. Let's suppose 8 months or 9 months or 1 year down the line. So this is the business need of it. This is the first thing that we need to assess. The second is the technical specification. So when we talk about technical specification, we need to identify that what is the performance expectation from the model. So we need to set the clear performance metrics such as accuracy, response time, so that we can evaluate that should we go about choosing the existing model or not. Second is integration complexity, because majority of these model needs to be integrated with your existing system or probably future build system. What is the flexibility that these models are providing in order for the integration? And third, which is the data sensitivity and security. So determining the sensitivity of the data involved and the associated security requirement and the risk is very crucial when it comes to deciding this particular factor. So this is the first step.
Right.
Now the second step is evaluating the existing SLM framework. Now, since you know that there are so many people or the development community, those kept on building those models and giving you further fine tuning, and you can utilize those models. Few of them are open source, few of them are not. Now, how should I go about evaluating this model? So this is the second step. So first thing is feature matching. So when we say feature mapping, it's simple as we need to evaluate if there are any existing SLM model, those are probably solving that particular problem. So let's suppose I would like to build a SLM model which can summarize my email. Is there any specific SLM that has been trained to perform this particular task? So that probably I can fine tune it, but it will basically consume my less efforts. Second is customizability. So there are so many models those are available, so many frameworks those are available, but we need to find out whether the customization is available on that particular framework or not. Second important is cost and resources. As I was mentioning, that we need to figure it out whether what is the development cost and the operational cost associated for that particular model selection. Now the third step, this is the second step. The third step is basically we need to figure it out that what is the possibility of custom development as well. Since definitely there are possibility where you need to rebuild the model or probably refine that model for any unique feature that you want for any choosing the existing model. So how do I go about it? Probably I need to figure it out what kind of unique features I need in that particular model, probably in the future, not right now. So, and then the third, and which is a very important part, and this we actually do it very rigorously with so many of our clients, which is performing the cost benefit analysis. So when we say performing the cost benefit analysis, we perform those analysis into two different segments. One is quantitative analysis, where we try to figure it out, understanding the by utilizing certain data-driven models to project the ROI for both the options, factoring the development cost, operational cost, and potential revenue increases. And then we try to analyze the break-even. For that, this is the quantitative value. And the second, which is also very important, sometimes the quantitative factor does not fits in, but the overall solution is actually creating the value for the future. So such as the brand value, the customer satisfaction, or maybe aligning with a particular future strategic goal, right? So this is what we call it as quantitative fact analysis. And then considering all such factors, we basically define a very customizable decision tree or decision framework where we actually help our client in order to take the decision that how they actually go about building such models.
Right.
Right.
That was really a comprehensive breakdown, Prabhanshu. And I think now hearing this, companies might be able to understand and decide in a better way.
Yeah.
Now, as we wrap up our discussion, I would like to know your opinion on what the horizon holds for small language models and where do you see them heading in the next few years? And what kind of impact do you think they will have on AI and our daily life as well?
Yeah, absolutely, Anmol. So, as we all know, the small language model are gaining a lot of traction as a valuable alternative to their large models counterparts because of their efficiency, scalability, and lower resource demand. Over the next few years, what we can expect is these models to significantly impact AI. So, the first factor that I'm thinking about is enhancing the accessibility and efficiency for the smaller and the medium-sized organization, because these models requires less computational power probably in the future and can be operated with a more cost effectively. So making advanced AI capability more accessible to the medium-sized or small-sized enterprises. This is the one factor. And the second, which is very important, is specialization and the customization. So one of the major advantages that what we were discussing is their ability to customize for the specific task without the intensive resource investment required for large models. So recent advancement in AI have shown the small language model can achieve performance better than their large language model counterparts. So this is the another future that I can see for the small language model. And the third part is definitely the sustainability, because these models will help us reducing the carbon footprint if I have to compare it with the large language models training and deployment part as well. And the another important thing is industry specific application, as what we were thinking that these models can be trained on to perform the very specific task. So we can see the significant implication for the industries such as education, healthcare a lot, customer services where SLM can be integrated into the existing system to provide the enhanced functionality without the overhead of the large language model, right? So if I have to talk about the future trends, as the field evolve, the focus will likely shift toward further optimizing these models for even better performance and lower resource usages. And this is what even we are doing here at Unthinkable. Techniques like model quantization, which requires the less memory requirement, and innovative training approaches, right, which will actually help us, optimizing and improving those models. Right? So this is what it is, and I think the future holds good for the development and the usage of small language model. And this is what we are doing. We are kept on experimenting and innovating here at Unthinkable Solutions, specifically for small language models and other AI models as well.
Right. Great insights, Prabhanshu. Thank you for that. And that, dear listeners, brings us to the end of a truly engaging episode. Thank you, Prabhanshu, for joining us today and shedding light on such a new, unexplored and captivating topic. It's conversation like these that remind us how technology continues to shape our future in the most unexpected ways.
Yeah, thank you so much, Anmol, and thanks for having me here on the podcast.
Now, I want to turn the mic over to you, our amazing audience. What are your thoughts on SLMs? Are you as intrigued by the potential as we are? Maybe you have got a perspective we haven't considered, or you are skeptical about something we discussed. Whatever it is, we are all ears, and we would love to hear from you through the comment section below. And if you enjoyed today's episode, don't forget to follow the Unthinkable Tech Podcast. We have got a lot more trending tech topics lined up, and trust me, you won't want to miss what's next. Catch you on the next episode. Till then, take care and keep listening.